Hello, hello. Can everybody hear me and see my screen?
Yes.
Thanks, Corbin. Okay, we'll give everybody a few more minutes. There's 8 of us in here. I like to wait until there's about 10 if I can. A couple more minutes and we'll get started. Okay, well, it looks like I lost one. Hopefully we'll have a few more people come back and we'll be able to get started. Let's go ahead and take a look at our syllabus. Scroll down, watch your eyes. Oops, here we are. So what we want to do is we want to continue working on wind introductions and tower safety today and rescue training. You're going to have a midterm pretest that will be opened up here. It covers modules 1 and 2. And I have not opened that up. I want to make sure that that one is ready to go. So we can talk about that one on Wednesday. So there's no hurry on that. But today we're going to be talking about some things from the big wind industry and working on tower safety. So we do have, I'm going to scroll back up. Today is the first time that we're going to be using our textbook. If you see, we do have a textbook that goes with this class. Now, you can get away with not using the textbook, but you want to have the textbook because I use it in the 111 class and I use it in the 211 class. And so those are really, it's a really good textbook to have, and it's one that I reference. So I'll be pulling that up today as we go through some of the information, for especially if some of you guys don't have a textbook yet. And we will discuss the information in it anyway during the videos, so the videos will be help as well. So if you were to go home you would see that we're getting into week 2. And you see under week 2, you've got module 2 and module 3 that you want to work on. So we're going to be covering a couple of modules a week because the book has 17 chapters in it. We're only doing about half of the chapters for this class and the half of the chapters for the other class, plus some other supplemental information as you've already seen. So today we'll start going through chapter 1 and chapter 2 in the textbook. Make sure that we're recording. Wind introductions. So module 2 has wind introductions chapter 1, and you have an assignment 2 that goes out of chapter 1. We have a lab worksheet that we will work on Wednesday. And then we have some learning activities that go along with that lab worksheet. You're more than welcome to start on it, work on it. You'll need to turn it in anyway, but it's got some math on it. So I have a feeling it's going to be one of those where we want to work on those in class so I can check your work and help you. And then on Wednesday, we'll do that worksheet at the very beginning. And hopefully everybody can get that done. And then we'll go over to the lab and we'll work on climb training, rescue training for the rest of the day. So that is the plan for this week. There's Rory.
Is there any, which module tab is the lab worksheet under?
It should be under module 2. So let's take a look. So that is your PowerPoints. If you click next, then you should see your homework assignment 2, 18 points in Canvas. So there's no submission there, you're just answering true and false. And this right here, I believe, is the lab worksheet. You may have to download this stuff. Canvas is having trouble since these are large files to have these PDFs in here. So if I click on that, you should see our lab worksheet, chapter 1, and there it is. See that, Peter?
Yeah, I see it.
Okay. And that's where I say you may want to wait. You can get started on some of the tedious stuff here. And you may want to wait until Wednesday, and we can work on that together. Let's see here. Okay. And what you'll find following that lab worksheet is you'll find the submission that you'll need to do for that lab worksheet. Yours will look a little different than mine, but then you have some examples. So if you're wanting to get started on it now, this right here will show you some examples if you download that. There we go. Let me close that. So for some of this math that you have to do, I've worked it out already for you. It looks harder than what it is. It's a formula where we plug stuff in. And so what we'll just have to do is get a couple of these going, and then you guys will work on a few others. So one of these formulas is over instantaneous power. The textbook talks about it. I find the textbook is a little, it assumes you know math really well. And I know my students are new at math to a certain degree. So again, I got a lot of help there for you. You have a sound power calculator here. You click on that. You can do this formula on a calculator if you would like. which I find that to be very hard and tedious, and you guys make a lot of math errors. The easiest thing to do is to just use this calculator here. And like I said, we'll go over that on Wednesday when we have a chance to look at everything together in class.
Is this supposed to be submitted to the fall protection training worksheet that's due today? I'm a little bit confused on which one it's supposed to be.
No, this is for next week.
Okay,
So this is a new assignment in module 2.
okay,
Module 1, so it'll have its own module. So the weeks at the beginning get a little confusing, but we're really in week 2. And you know, like week 3 starts like on Wednesday for us, which is weird. But anyway, what you want to do is just look at your due dates and look under each week that we're on, and then work on those modules for that week. So this will be something that we will do together in class, and it'll go a lot faster. It won't seem so much extra work. Okay. So you can wait on that, or you can get started on it. You've got the power calculator here. What I like to do with those worksheets is I expect everyone to show up on Wednesday. I like to print them out and just have you hand them in to me. And then we don't have to do a big submission. So that's one way to do it. If we got to do it through a submission, you can bring it up to me and I can check it off that way as well. So the worksheets are like, you know, they can be 10 pages long. That's a lot of pictures and things that, you know, don't work so well. So that's why I also say like on Wednesday. But if you want to get started on it, it's there. If you want to print it out, you can print it out. You've got some examples in here to help you start working on it. There's also an example in here on how to do sound on some of the questions that they have. Okay. So let me go back home. So when you go home, you look under week 2, module 2. So that's where we just were. And what I want to do first, well, first of all, are there any other questions for me? I'm trying to organize this information the best that I can, so you guys aren't too lost. Always just look at what's under your module here. It'll list everything that you really need to do. Okay. Now I'm not going to use the PowerPoints here. They're short and they leave a lot of information and stuff out, but they're good cliff notes. So if you want to use those when you follow along, that's fine. Right now, I think I want to use the textbook first, just because I feel like some of you guys aren't seeing the textbook. So just let me check right here. Can everyone see chapter 1?
I can see it.
yes.
Yeah.
Yes. Okay, good. That's what I want to make sure, that I got the book open and we can read it. Okay, so for those of you guys that don't have it, I'll just be following the textbook along in these chapters. So we're going to be covering chapter 1 and chapter 2. They're not very difficult. The math in them seems a little hard, but that's what the worksheets are for. And so we'll go through the worksheets together, do that. We have to do math as part of our accreditation. So these are some of the math problems that we work on that are in the book. And you know, they serve a purpose for you to get into design, to thinking about design a little bit more. But there's a lot that's covered in this chapter. So what the objectives are is they want to talk about the trends in the wind industry, which this book is older, so it's a little dated, but the trends are still the same. And we've looked at that in a couple of our classes already. We're not going to go back through all of that information. Identify some wind turbine manufacturers. We're going to look at the components, the main components. So this again serves as a good introduction. It has some good information on career paths that are available to wind technicians, different types of roles. So for a first chapter, it's pretty easy. It does have a lot of different information there. So at the very beginning, it's just talking about how wind didn't really exist until we started to have things like the manufacturing sector from Henry Ford to cars, and then we fast forward and we get the production tax credit, which the production tax credit is a law that comes and goes. So we have one now that's being phased out. They may make a new one. And what you notice is whenever we have a tax credit that goes along wind, we see a larger growth in wind. So that's just the point of that. We also noticed that we had the oil crisis in the 70s, which we've talked about many times. And that pushed a lot of people to renewable energy. So that created a renewed interest in wind energy and the early 80s and 90s. And we started to see that for the first time, we were able to start to build some small wind turbines. They're nothing like the ones that we had today, but we were starting to build little turbines. And then we fast forward to today, where we've got China, USA, and I don't know, I'll have to look, see who has the most wind turbines in the world today. It's generally been between USA and China back and forth over the years. China's got quite a bit of wind as well. So it's made great strides, is what they're saying, over the past decade. We can see pictures of different early wind farms that they have, particularly these right here, these lattice towers. These are really small turbines that they had generally out in California. And when they had those out in California, you know, they were one of the first wind farms that we had in the United States. Some of these older ones still around, but they've been replaced by the newer tube type towers. So this brings us to our first equation. And the equation is really, this is the power equation that goes along with our worksheet. We're not going to sit here and study this in great detail right now, since we'll do that together on Wednesday. But what are they trying to show us? So there's the formula there that has some constants in it. What they're trying to show you is simply the very fact that if you use this equation and you're trying to determine how much power is available, what you find is the swept area, the larger the blades, the more power you're going to get. The taller the tower, the more power you're going to get. So that's one of the ways that we can increase our power, by having a larger wind turbine. There's Bett's law that comes into play. Bett's law says at some point a wind turbine can only get about 60% of the available wind, because it'll become a wind dam if it were doing 100%. So it would be spinning so fast that it would block the wind. It needs to have the wind run through it to actually capture it. So, you know, technically wind turbines are never going to be at 100%. And plus, we have several problems with when it comes to the efficiency of the system. So every system is a little different on how efficient it is and how it runs. So there's a coefficient that goes along with that. So that's part why we're looking at this stuff, and we're gently touching on it and learning about it and doing some equations on it, and then we're going to move on. Any questions so far? They're just showing some pictures here about the blades, showing the different ways they're manufactured. It explains how those are challenges that we had to overcome. We had manufacturing issues. How do we make 50-meter blades? We've had to discover out how to do that. How do we transport 50-meter blades? How do we assemble these huge turbines with cranes? All that was stuff that was getting worked out into the 80s and 90s to get us to where we are today. There is bold type nacelle. Nacelle is the machine head, or this part of the turbine. So some of these terms you may be familiar with already because you've already taken a wind class. If you've never taken a wind class before, this is the first time. This chapter does a good introduction to some of the basics. And so that's one reason why we got to go back over this stuff. Tower assembly. The towers are stacked, tube-like structures. So this is just talking about how the tower is put together. You can see that they can put the blades on the ground and raise the hub all together, or they can raise each individual blade. They've done it both ways. Then it gets into talking about how over the years we've overcome the challenges to manufacture these wind turbines, and we've come to today's type of turbine. And a lot of that has to do with the power control systems. So inside a wind turbine, it's just a giant robot. And the thing that we have is when we have nuclear, natural gas, coal, biomass, they heat water to generate high steam pressure that flows through the turbine to spin the generator input shaft. Hydro projects use the controlled flow of water. So all of these fossil fuel type competitors to wind, they have one advantage, that their fuel source isn't variable in the same way that wind is. So wind is at the mercy of wind, and we need to find a way to deal with the varying RPMs. That was one of the earlier problems. So there's a couple formulas they have here. So they have a power formula where you input torque, RPM, and take it by a constant. And then we also can determine the frequency. So there's an example over here where they're showing a couple of these formulas. I don't think they're very good examples, but if we were to look at the RPM one, if you want to know what RPMs you run at, you have 120. This is the formula now, flipped around. You have 120 times the frequency, and our frequency is 60 hertz. So we're always going to be putting 60 in there. And then we need to know what type, how many magnetic poles are in the generator. So you'd have to look that up. You could also flip this formula around a couple different ways. If you know what the RPMs are, you know what the frequency is, you can also determine how many poles a generator may have. But you have to have some of the information to be able to do that. And so what they're saying right here is if you got a 4-pole generator, it has to run at 1800 RPMs. what that means is that this turbine can only really make power if it's a synchronous generator when it is in the range of 1800 RPMs. If it's not in the range of 1800 RPMs, then the wind turbine doesn't work. So that's one method. So we don't like to use synchronous induction generators. We like to use asynchronous induction generators or doubly fed induction generators. And that's the type that most of you are familiar with or have you'll be working with. So this method is called wild AC. So where we have a generator spinning at a speed that is going with the wind. So as the wind goes up and down, the actual blades are spinning up and down at different RPMs. In order to fix that, we have to use, let's see right here. We have to use a frequency controller. So the easiest way to understand that is this is a power conversion system. What it does is it uses a rectifier, and a rectifier takes that wild AC power that's going up and down with the wind, the sine wave, and changes it into DC. Once we have DC output and we've converted or chopped the sine wave in half to where we're just getting DC, then it's going to go through an inverter or a piece of an electronics. And that inverter is going to take and allow us to run that generator at different speeds, because we're still stuck in a range though. We can't go from 0 to whatever. We still are in a range of wind that's usually about 5 mile an hour to 45 mile an hour where we run. It depends on the type of wind turbine, but they can start producing power at a much lower wind speed because of those power electronics that are taking that wild sine wave, cleaning it up and turning it into a 60 hertz sine wave through electronics. And so it may not be that much power at 5 mile an hour wind that we're getting versus 45, but we still can turn it into usable power that's the same frequency as our grid. Does anybody have any questions so far? So that's where they talk about doubly fed asynchronous generators, which is basically what I just explained. So we're taking and seeing what the grid is, and then we're using electronics to try to match or sync up with the grid. And that's what we call our control system. So we have a control system that does that. Any questions over how any of that works or any confusion there? I think most of you have had it before. And there's still a lot to learn about it, I know. Public acceptance of wind farms. The chapter talks about how there is always people who don't want projects in their backyard. So when we do these projects, we have wind resource studies. We're looking for things on the land, the geographical landscape. We're trying to find where the best transmission is. You have the Environmental Protection Agency get involved. You have the FAA get involved, making sure that you're not disrupting any flight patterns. And so those are some of the challenges that some of the public acceptance of wind farms has. If you do get a wind project on your property, you generally get land use royalties. So if you have, say, one wind turbine on your property, then this talks about how depending on the contract you have, you may get $5,000 or $10,000 a month extra just to have that on your farmland. So that's one reason why we call it wind farms. This is a wind resource map. We'll have several of these that we need to look at. They're hard to read. I'm going to give you that. I'm not a stickler on it. It's just like kind of look at it, get an idea of what the wind resources are in those areas, and try to determine what the wind speed is. Let's see here. Taxes can be brought into your communities. So they'll build roads, they'll donate money to the community. Wind farms try to do a lot to try to help the communities when they come into the communities, help pay for schools. There's a variety of things that they do. There's another wind speed map. Then the chapter goes on into wildlife conservation, discussing things such as birds or worries about birds, natural predators. It has a nice little chart here that shows the reality that most deaths per year are with other types of things, mainly cats. Cats kill more birds than wind turbines. You got pesticides, you got oil, you got waste pits, you got, you know, all types of things that kill birds. So, you know, how accurate this chart is, I'm not real sure, but I know that wind turbines aren't the worst one, and they're not as bad as everyone makes them out to sound to be. So it's just more of a political thing. The aesthetics. Do we want a wind turbine in our backyard? It's really just up to you. That you look at some other places where they do painting schemes on them, where they may paint stripes on there to help airplanes, or they may paint the tower green to help it blend in, which seems kind of wishy-washy there. You know, and then when we put these towers up, we got to put them up on the hill, not down in a valley if we can. And we may have to run buried transmission lines over to the towers. So that's another issue. You know, decommissioning is another issue. If we are working with wind turbines and we need to get rid of them once they're older, generally all of these wind farms have a insurance, or they have a contract that says once they're done, this is how they're going to come down. Noise impact. So noise impact is another one, like birds. How much noise can they have? Well, we learned in our 101 class, we did a study where we seen how the sound is perceived, and they work really hard at keeping everything down below 45 decibels. So this is where they throw in this somewhat complex formula for working on the equations. And really what you really need to do is just use that calculator when we work on our formulas. Okay, because they're pretty hard. But if you want to see how it's done, they have an example here. Wind industry trends. Do we go with a gearbox or do we go with a direct drive? Gearbox is what we generally go with, although there are more wind turbines that are becoming direct drive. How would that work? if you were dealing with a gearbox, you can have less poles. If you have less poles, that means, say, we only have 4 magnetic poles, then our RPMs are going to be around 1800. And then we're going to have a gearbox with a gear ratio of, say, like 50-1, so that our actual blade RPMs are only spinning at about 20 to 30 RPMs instead of 1800. The generator may be spinning at 1800, but the blades are not. If you have more magnetic poles, then right here they say if you have a direct drive turbine and it's going to spin at 20 RPMs, that means that the direct drive generators are going to need to have a lot more magnetic poles inside. So they've gone both ways, but that's just a bigger, more complex generator versus having a less complex generator and having a gearbox to deal with. You'll find that many of the wind turbines that are out in the ocean or out in the waters, they generally, there's a lot of them that are direct drive, just trying to minimize, and they have bigger generators as well. Any questions or comments so far? The next section is just talking about establishing a basic skill set for wind technicians. So this is just talking about different schools, how the Department of Labor, OEA, have worked with schools like ours on developing programs for wind technician certificates, apprenticeship programs, or associate's degree programs. So there's not a whole lot there really, guys. I like this table here. Let's see here. I'm gonna scroll to here first. And if you're watching the video, you know, I try to stop and pause on this. So if you're using the videos to try to read through this book because you don't have your book yet, you know, you can pause the video as I go along and read it, which I'm assuming you know that. But it's one reason I'm going through it like this. When you are looking at the different jobs, this is a really great chart that talks about some of the things that a wind tech needs to know, such as mechanical skills, troubleshooting skills, repair replacement, general maintenance, communication skills, electronic skills. There's a variety of skill sets that go along with being a wind tech. And how many of these skills that you guys get is really just a matter of time. You gotta go through a program like this, get your basics, then get a job, then pair yourself up with some more experienced techs, especially if you're wanting to get into troubleshooting, and try to learn from them on the particular turbine that you're working on. And then you'll start to round yourself out more and more. And you'll find some area that you want to maybe specialize in. So if you want to work on electronics, electrical equipment, that's one area where you can specialize in troubleshooting. There's still troubleshooting that goes along with mechanical systems such as valves, actuators, hydraulic systems, even bearings and couplings. There's also blades. Blade inspections are generally going to be done by people who are trained to do a blade inspection. So I wouldn't worry about hanging off a wind turbine with ropes to try to do blade inspections. They generally bring in a third party to do that, or they have some special trained people that will do those inspections. You may have to be part of the crew where they take the blade down and replace the blade, but that's generally another area of work that you can get into. So it just depends on the wind farm that you're on and what they are due and what your contract is. So that's something you want to ask. And I wouldn't worry. They're not going to just say, okay, tomorrow you're going to go hang off the tower with the rope and do inspections on blades on like your second day. That's probably never going to happen. Okay, so the next area here is career paths. So here, let me scroll up a little bit. It's just talking about some of the different organizations where you can get all your skills and then it goes into the different career paths. So the best thing to do here is just to look at this chart. So there's a variety of areas that you can get a job. Site development, site construction. You could do equipment construction where you work on the building of the actual wind farms. The transportation, the truck drivers that drive these blades around, they make good money. They make $150 an hour. An installation tech, someone who is installing, that's a lot of what I was for a long time, installing the cabling, the control systems, setting up some of the main systems. Commissioning technician, I've been a commissioning technician. It's where we build the tower and then we turn it on and double check everything and make sure it works. You've got an operation technician, which is what a lot of what you guys are going to go into. Service technicians, maintenance technicians, and operation technicians do mainly the same thing. You're troubleshooting, working on the electrical, mechanical systems. So you'll notice, you know, they've got even high voltage systems, safety guys, got wind farm managers, got people that work in manufacturing. You've got field engineers. Some of you students have graduated and become field engineers where you're not in the turbines anymore. You're going out into the field and doing field studies and assessments and looking at the different wind farms you have or potential wind farms that you may be working on with the company that you work for. So you'll find a lot of opportunity in the industry itself and some of the companies. So that's something to think about. This just lists off a bunch of schools that do the training. So we're not on this list. This, you got to pay to be put on this list, I'm sure. But that's just something the textbook has. And that's pretty old list. They got that from 2011. So some of those colleges may not even be around anymore. Utility grid, electrical infrastructure means simply if we're going to need transmission lines, a switch yard, transformers, substations, easy stuff that we should know. Then it goes into some of the basics of the way a wind turbine is built. Look at the foundation. Do we do a typical foundation where we pour concrete and lay rebar in like a pyramid? Should have a couple pictures. This is showing you a direct drive system. You can see in this type of wind turbine, which looks a lot like a clipper, and we have clipper wind turbines around our area. They don't have a gearbox. All they have is these 4 generators in the way that they do it. But they had a lot of problems with it. So that's one reason why you don't see a whole lot more of the direct drives versus the traditional. You know, and having a gearbox is important because you got to recognize how much torque and all the forces the wind is putting on this turbine, it just helps spread that torque out. If you have a direct drive system, a lot of that torque is directly forced upon the generator and the components between the generators. So there's not much there to handle the torque. So there's one of the reasons why a lot of manufacturers still go with the gearbox. DTA, that's something you want to, it's bold type. That's the very bottom of the tower, the basement. So when we talk about a wind turbine, next page is going to show us some pictures. This is good here. So we can see how a foundation would be put in the ground. They drive these rods. They pour a bunch of concrete. When we look at what is the DTA, that's going to be the bottom of the tower. They have the DTA outside of the tower here, but most of the time the DTA is in the tower, in the base section. Then we have mid, top tower. Then they have the nacelle, or what they call the machine head. And then we have the hub with 3 blades. So center of this being the hub, or what we also call the rotor. They're showing a picture of if they were to do a pyramid type foundation. We'll look at foundations in a little more detail in another chapter. This is just trying to give you an overall view of a wind turbine, a large wind turbine in of itself. So those are a couple of pictures of the DTAs and different types of turbines. It looks like a GE turbine at the very bottom when you walk into it. Then it goes into the machine head, talking about the different components in the machine head, which could include the control and communication electronics, the drive assembly, the generator, power conversion electronics, heating and cooling equipment, yaw control, pitch control, braking systems. Those are all in the nacelle. Here you have a diagram of the nacelle talking about, in this case, they have the transformers in the back. Then they have the wind anemometers and wind vane on the top. Talk about the pitch motors here and the blades, the bearings, a hydraulic system potentially right here. And we have our bed plate, or the frame that all this sits on. We have our generator, and inside our generator, we've got a cooling system. We have our gearbox here. And then we have our high-speed shaft right here. We have our low-speed shaft, and this is usually where our brake is as well. So you've got all of these things to look at to help you identify the different parts or pieces of a wind turbine. Any questions on this diagram? Okay, 9:20. We've been going for about an hour here. So that's what we call the rotor assembly and the drive system, where we have the blades and the nacelle all put together. And then lastly, the pitch system being the blades, or the rotor assembly also houses blade, pitch control electronics, or mechanical linkages, depending on the manufacturer's pitch system. Here they go in to show you some different pictures of different ways of doing it, where you may have a pitch bearing, pitch motor. So this is just the inside of the hub. This is a blade. These aren't the greatest pictures. Then they talk about a couple things on different towers. So some towers have the transformers at the top in the nacelle with the power conversion system. Everything's up there. And you've got your main disconnects down at the bottom. One thing they show you is the drip loop. Drip loop is something that hangs down in the middle of the tower when the wind turbine is turning. That gives it a little extra slack so it doesn't pull these cables tight. You look at this example here, which is more common, I found, where you have the same idea. You have a drip loop, but in this case, you have your transformers on the ground outside, and you have most of your power conversion control equipment and your disconnects, your main switches, all down in the DTA or the very bottom of the tower. Next page. It goes on talking about preventative maintenance, the importance of preventative maintenance to try to get a 20-25 year lifespan out of a wind turbine. And you want to get your return of investment. So that's where the maintenance guys come in, when your job is to try to keep this wind turbine running as long as it can, so that the investors and stakeholders can actually make a profit and reinvest into more wind. So when they talk about the importance of preventative maintenance program, it's all about availability and making sure that the wind farm has most of the wind turbines available 95% of the time. So that means you don't want a bunch of them broke down. And when they say you have a certain amount of them broke down, then this percentage is going to drop from 95 down to 90 to maybe 85. And if your contract says you need to maintain 95, that's a good way to lose your contract as a group. So everybody's got to pull their weight. Safety, we know safety is important. So the next section is going to be mostly review. It goes into tower safety, and we've had a lot of tower safety already, which is good. So that should make that section go pretty quick, but it's important to make sure that you read some of this stuff when we're dealing with our safety equipment, and try to get as much information as you can before we move on. Okay. This is just giving us a summary here. We're not doing these review questions, so you can just ignore all that. And we'll start chapter 2 here. Now, before I do that, let's get back into our modules here. So what we've done then is we've gone through module 2. So module 2 is wind introductions. We just went through the chapter 1 PowerPoints. We covered all that. You have 18 questions over that material that we just went over. You got 3 attempts. So here in this case, you're choosing the correct definition to go with that. So you've got a bunch of bold type words in there, which is the nacelle, what is a rectifier, what is a rotor assembly, what is wild AC. Then you have a bunch of multiple choice questions from the information that we went through. And we can work on this on Wednesday. Okay. Or try to do it on your own. So that's assignment 2. Okay. Then we're going to also do module 3 today, so we don't get behind. So when we look at module 3, we're going to take a short break, just a couple of minutes here before I get started on that. Module 3 is covering a lot of the same stuff that we covered in the fall protection competent rescue training course. I like you to go through that competent protection training course because it helps you see exactly what that would entail instead of it just being a chapter in a book. The book kind of follows the same ideas, but it does it in a little more, I think it's a little too quick, but it's got a lot of good pictures to go along with it. And so you'll have your assignment 3 that goes along with that chapter as well. This stuff should start to get a little easier as long as we go over it a few times. And then you have a worksheet that we'll be working on when we have that as well. And then you got a little video on here on watching how they do rescue training. So before we start here, let's take a short break and I'll be back in just a couple minutes. Okay, I'm back. So let's go ahead and let's see what's in chapter 2. Before I do that, let's look through this. So you will find your chapter 2 PowerPoints here. There's 34 PowerPoints, good cliff notes. There is your assignment. This is going to be really over safety stuff. Okay, so you had your worksheet that you did once. Now you should be learning more about the safety stuff. You got a lot of true and false questions here. Okay, and then the basic steps for tower rescue. And this, multiple answers are possible, so you need to click more than one of these. And that's from your textbook. Okay, so what we need to do is understand the need for safe work practices, discuss why we have to have a safe work attitude, talk about some of the organizations that regulate and enforce the safety, discuss methods of preventing injuries, document and use an emergency rescue plan. Know what a tailgate meeting is. Practice tower rescue activities, which we'll start to do on Wednesday. Understand how to document safety inspections, which we've talked about that already in class. So they go over that again. Look at some of the hazards of working at heights. Understand what a fall arrest system is and discuss a tower rescue plan. Some of the basic steps. So safety is important, we know. So the text starts talking about first looking at why safety matters. What can we do to prevent a safety accident? So they go on talking about it's a mindset where you need to be always prepared for an accident. And at the beginning of each day, you'll see a job briefing or tailgate meeting. That tailgate meeting is important for you to understand what is going on during the day that you'll be doing to make sure that you know if you're working with electricity or hydraulics. That tailgate meeting is where your supervisor lets you know of the different dangers, and everybody should sign that. Then we have our basic government safety regulation organizations such as OSHA, making sure that we all work according to the standards. That goes into play with ANSI, as we talked about Z359, ANSI standards being part of our harnesses and making sure that all of our gear meets those standards and what those regulations are. So it goes into talking about the top hazards for the wind industry. So there is falling from a tower or a nacelle. That's obvious, right? Being struck by a falling object. That could be somebody dropping a tool. I've seen that happen before. Shocks, electrocution. Those are the top hazards in the wind industry. So that's a homework question. And it goes into talking about how do we get rid of some of that stuff? Well, there are 3 fundamental practices to eliminating and reducing hazards in the workplace: engineering practices, management practices, and use of personal protective equipment. So there we can see a couple wind techs on the top of the tower. And then we have a list here of engineering changes that can be done. Where falls, we could add handrails, guardrails, warning lines, restraint systems, ladder cages, doors. These are suggestions that you could even make while you're on the job, so they can make those improvements. Falling objects, they could have overhead barriers or different guardrails, pinch points, guards. There's a pinch point close by. Then we have to deal with the rotating shaft of things, where we have to worry about our hands, our fingers, our clothes getting caught and pulled into a rotating. So any type of barrier that can be put into place. Electrocution. That would be working again with barriers and the proper PPE. So those are engineering things that we want to try to eliminate the hazard before we ever have the hazard come into place. Then there's management. Management practices are where you guys change the way your policies, the way that you do the work, and some of the training that you get to try to help you perform your job safely. So there's a lot of training in regards to this. So some of the hazards may be falling. Well, you only climb when winds are below 20 meters per second or 45 mile an hour. Do not enter the hub unless winds are below 15 meters per second. Only qualified employees approved to climb. Overhead hazards, do not get within 1,000 feet of a turbine if the conditions can create ice falling from the tower, nacelle, or blades. Do not leave your tools where they can fall, where they're not secured. Heat exhaustion, make sure you stay hydrated. Electrocution, only work on stuff you've been trained on. Don't just go work on something you don't know what you're doing, don't do it. Cold water, that's just if you're dealing with offshore wind turbines or water survival techniques, which is something I don't have any experience with, but you can imagine. So those are management practices that come into play when we're working through some of this stuff. Then it gets into personal protective equipment. Knowing your PPE is important when you're working at heights. Okay. PPE would entail things such as earplugs. We know that anything above 85 decibels can cause hearing damage. Any type of cold weather, make sure you're wearing cold weather equipment, jackets, hard hat, full body harness, lanyard and anchor. When it comes to your feet, steel-toed boots or composite-toed safety shoes, cut-resistant gloves. Make sure if you're in a poisonous atmosphere, you got a respirator of some type. If you're doing underwater work, which would be really kind of crazy, that would be somebody who's trained to do offshore wind towers, underwater work. Arc flash suits. Make sure you're wearing the right arc flash rated clothing if you're working, say, in a transformer. Sunlight, safety glasses for your eyes, chemical exposure suits. So a variety of PPE. Then it goes into our fall arrests equipment, which we've learned a little bit about already. We know we need to have a full body harness and a twin leg shock absorbing lanyard and a ladder safety device, such as our cable glides, which we all had a chance to work with. They talk about, in addition to your basic fall arrest system, that would include any type of anchorage or connectors. So it's going to go through all of that stuff, looking at different connectors, bad connectors, good connectors. Horizontal lifeline, that's just a cable system they don't generally use in wind. You could say we have a horizontal lifeline on top of the turbine. We have a bar up there that's in place. So there's just a couple pictures of your different harnesses and the different equipment. Full body harness, got a double-legged lanyard there, cable glide, hard hat. This looks like another type of harness or lanyard. And there's another type of lanyard. Different type of shock absorbers is what you're looking at there. This goes into body belts. Just showing like in the 90s, they made body belts illegal. Because if you fall right here, you could have eternal injuries, back injuries. So we know that when we fall with a force, we have a free fall, we fall with a force of 5,000 pounds, right? So they bring that back up. The purpose of a fall arrest system is to reduce the impact of the body through decreasing the fall distance and absorbing some of the kinetic energy. And body belts don't do a good job of that. We need to make sure that we have the proper clearance distances. So fall clearance. We talked about that in our first class, where we have 6 feet for lanyard free fall, 3.5 feet shock absorber deacceleration distance, 1 foot for slide in your D-ring, 2 feet safety factor, just to make sure you don't hit the lower surface. So we have a total drop distance of 12.5 feet. So we know that we have to be at a certain height or we will still hit the floor if we fall. So if we're 6 feet up, 6 foot lanyard isn't necessarily going to protect us. Any questions on anything so far? So they go into talking about body support, full body harnesses, your D-rings, know what your D-rings are, know what carabiners are. You should all have a pretty good idea of what that stuff is now. We haven't worked with the work positioning lanyard, but we've looked at one. We'll work on that on Wednesday. Okay. Inspections. Daily inspections are before each use. You want to be looking for, as we've noticed, rusty, bent clips here, deformed D-rings, anything where our harness looks like it's been damaged. So we talked about that in class. We've seen a couple bad examples. And we got to worry about the threads, the stitching, and exposure to chemicals, exposure to UV sunlight. There they're showing you examples of all the different stitching lines. These are trauma straps right here. We haven't learned about those yet. We will. You got to watch out for your rivets, or even like in your belts where your webbing has been damaged, or your grommet, what they're calling a belt grommet, it's been bent, or it could fall out of this strap. And when we clean these, you use basically soap and water, no chemicals, let them air dry. When I worked, we had a safety guy, and he would take all our harnesses once a month and do a full check on them in addition to our daily checks. So you've got your monthly checks, and then you've got your yearly checks. And again, that's a job that some of you may find yourself getting into over time, safety. It goes on to talk about how you put on a full body harness. All of us have learned how to do that already. So that's easy. Just throwing you, put those straps on. Spacing between your hips and the web strap should also be around 2 inches when you're standing straight up. So we talked about sliding your hands with your fingers. Try to make sure you have maybe about 2 inches of room on your leg straps. It talks about false connection again. There's another picture of a false connection. Make sure it's not just poked in that hole. It's actually locked in there. Okay, we talked about care and cleaning already. Talked about making sure there's no oil, grease, paint, even sweat will degrade the harness over time. Check your connectors. Make sure all your snap hooks are in good condition, that there's auto locking, that they can handle the weight load. They're supposed to be able to handle 5,000 pounds. Okay. There, just showing you pictures of different snap hooks. SRLs we haven't used yet. We will use them. We have an SRL. So an SRL is going to connect above you. It's kind of like a seat belt. If you move too fast, it'll lock. So if you slip and fall, it'll catch you. That's what we use when we have to do improvised safety climbing. Ladder safety device, cable glide. Okay. That's an SRL right there. So it'll allow you to move quite a distance, 15 feet up and down without you worrying about falling. There's a different kind of cable glide. This right here is showing you another way that they do it. There's the cable glide that we use. Make sure they're self-locking. Opening snap hooks or carabiners, they twist. As we've learned, make sure that they twist and lock properly. Goes on talking about visual inspections of webbing, rope material, burns, holes, abrasions, anything like that, missing stitches. Make sure you inspect your shock absorber, looking to make sure your impact indicators have not been used or stretched already. Sometimes people will hang by their lanyards and pull those things out if, just because they're resting or leaning. That's not good. There we can see a damaged snap hook. It's not closing all the way. I'm not always sure what they're trying to show us in these pictures because they're not the greatest pictures. But they're showing us some dirty, tore up straps there. Remind you to check your rivets. see if any of the rivets are missing. Defect in your lanyard strap, like right there, you can see the rope is tore up. Here, it looks to me like this impact indicator is ripped out. You've got manufacturer labeling requirements, looking at those things, making sure that you've got the right lanyard for the job. There we can see a lanyard that's frayed. So a lot of repeat information here. Should be able to get through this pretty quick. And we see our trauma straps. So those hang off the side of your harness, and then they connect together where you can put your feet on them and take the pressure off of your legs if you were to fall. Because if you fall, then you have the risk of getting a blood clot if you're hanging in your harness too long. So you want to be able to try to take the pressure the straps are giving you off of your legs. So those are trauma straps. Lanyard keepers. You have these cables that go up and down the tower, and there's these little rubber grabbers, lanyard keeper type deals that can help hold those cables in place. Work positioning belts, a couple different kinds. Reminding you to hang your harness straps up high, mounted on your full body harness, not down low on your D-rings. Okay. I think we're getting close to being done with this chapter. Yeah, and then they talk about tower rescue. So tower rescue is really something that you're going to be training on at the job site regularly. What we just want to highlight is what it would entail. How would you get out of a tower if the tower was on fire, or you had a lightning strike, you couldn't climb down your ladder for one reason or another. You had to go out the back of the tower, which is going to be very, very rare. So in order to do that, we need to use a rescue system. We're going to watch a video on that here as soon as we get done with this. So what you need to know is there needs to be a qualified technician who knows CPR, who knows how to do basic first aid, possibly knows how to use an automatic external defibrillator. If you should have one of those in the truck. This is a roll gliss. This is what we'll be using when we practice this training. You may have seen it in class, but we didn't really focus on it. Rescue or evacuation. The two types of rescue can be used for a fallen individual, which is going to be self-rescue. That'd be, can you pull yourself back up? That's simple enough, right? And then there'd be assisted rescue, where you're going to need help. Someone's going to have pull you up, either with a rope grab device to grab onto your lanyard and pull you up if you're on the side of the tower hanging. For some reason you fell off the top of the tower. and you can't pull yourself back up. There are assisted rescue. You can even use a roll gliss to do that. We'll have to learn how to do that. It's got a crank on it where you could crank on it and help pull the person up. As long you could throw down the rope to connect to them, they could connect it to the harness, and then you start cranking, and then they'll start being able to climb up. You could use a soft ladder. This talks about the basic rescue steps in a rescue. So call for help. That's the first step. When you notice someone is hurt, use your radio or cell phone. Assess the situation. So the next step, is the person conscious? Is the person unconscious? Is first aid necessary? That's going to determine if you need 911. Is there a medical emergency? If you need to assist, what do you need to do? You also need to ask, will the rescue put me in danger? So why, if I go try to help them, am I going to be in the same situation they are? Assist with self-rescue if the colleague is conscious. If they're unconscious, you pass along the initial assessment and get help. You set up your rescue equipment, and then you perform the rescue. You perform first aid if needed be. Okay, and then just like any other type of equipment, you're going to be inspecting your equipment, your tower rescue equipment before each use. You don't want to hang off the top of the tower if you haven't done an inspection on this equipment in a long time. So that stuff should be regularly inspected, making sure there's no damage to any of the components. No rodents have gotten in there and ate on the rope or made a nest. That's one you have to worry about. Okay. So that wraps up chapter 2, which is review over our fall training. So you should be able to go through that chapter really fast. You may know most of the answers already, and you should be able to get through that homework pretty quick. Is there any questions? Okay, we're not going over chapter. Okay. Thanks, Court. Okay, pretty straightforward stuff, I know. All right, let's go back to our modules. And one thing I want us to watch is a self-rescue before we wrap up today. So this is a little more interesting than just looking at a textbook. We also have our worksheet 2, tower safety. So that one's a lot easier than the other ones. So we'll be working on that on Wednesdays as well. We'll get those done as fast as we can get those done. We may not be able to get them done right away, but like if we try to work on one worksheet and we only get partially one of them done, and then we want to go climb, that's fine. I'll be checking in with you guys on these worksheets and working on them with you. Let's take a look at a roll grist training on how that would work. So I'm going to go ahead and pull this video up. It's one reason why you need to know how to tie rope knots.
सिंपल वाला मार के दोनों जॉइंट करके मार देना ये आपका गोल करके दोनों जॉइंट करके मार देना और एक फोल्ड करूं एक और मार लूं ठीक है थोड़ा भरा दो
There's their roll gliss set up where it's supposed to be. That's an engineered connection. They're going to open that hatch up here shortly and send this guy down. This is a real person. So say you fall down and break your leg and you're not able to do this work or climb down the tower.
आपके पास ये है ना उधर वीडियो निकाल रहा है ओपन दैट डोर और रोप छोड़ दो नीचे ओपन दैट डोर अरे पेट्रोल ये देख केंद्र वाले की पोर्ट वरना नहीं आप दे दे
all set to release the victim down now. All anchored. All anchored.
Hello, enter jaldi. Okay, very fast. Put that another one. Okay. Now what we'll do is we'll push him down. Okay. What you have to उसको थोड़ा नीचे लेना है. Okay. That guy. You have to pull this rope. Leave that rope. उसको छोड़ दो अभी. उसको छोड़ दो.
Leave that rope.
छोड़ दो. ये वाला खींचना है आपको. ये वाला. हाँ वो वाला. Okay. देखो ऐसे we'll push. You will pull. And then finally you push. Your name? Anish. Anish. You hold it here. Okay. Okay. It will be very heavy. अपने को क्या करना है? Just वो टाइट हो जाएगा. And he goes down. नीचे आ जाए. हमको छोड़ देना. Okay. हम लोग पुश करेंगे. आप लोग खींचो. खींचो. ये खींचो पहले. अच्छा खड़ा करो. उसको नीचे ला दो. नीचे नीचे. एक खींच. रोप खींच. रोप सेंटर रोप खींचो. खींच. खींचो. Wait. Anish. Okay. Leave it. Anish, leave it. Rope short. Leave it. Rope short. I told you should not hold it. Hello. Here. Okay, तो ये जितना फ्री रहेगा ना अगर इधर सेंटर में जाना ये पुट किया ना नहीं तो ये रोप है ना फिर से घसेगा ओके टाइम से करने की जरूरत नहीं सकती तो हाँ तो ये जरूरत नहीं है और वो वेट में तो जाएगा इट्स वेरी रेयर दैट जब ज्यादा दूर होता 10 के ऊपर तब वो
Successful.
yes
The victim has successfully gone down from 90 meters height from the wind turbine.
90 meters.
the advantage here is this is at the back and it is in the center.
I wish I could find one of these that are in English, but that's the one I found that worked pretty good. So I just thought that we'd look at that. We're going to be working on our roll gliss where you guys are going to be on the tower and you're going to get a feeling for what that feels like when it drops you down. You don't have to do it, but it's something that we will work on. So that is all I have for today. Is there any questions for me before I turn you guys loose?
No.
Tyrant, okay. Yeah, so hopefully this lesson isn't too difficult. It's not meant to be a difficult lesson. You guys got a lot of new stuff coming up and stuff that you're working on. You're going to have some tests coming up. So I'm just trying to give you something to where you just get your basics down and get your homework done, get that turned in, and then we'll move on to stuff that's new. All right, guys, I'll let you go and I'll see most of you guys hopefully at 1 o'clock. Have a
See you,
good day.
See you, John.
See you guys.
Right.
Bye-bye.